should be, and from there, what people's expectation, and then how actually they are looking whenever they are talking to you guys, right? So just make sure that you are noting down things, and if you want to go in your own way, it is good. Go in your own way on it only. The only thing is like I just wanted you to be best there, so that whenever you are going for any technical discussions or formal discussions, you should understand like what to how you should counter that question, right? And how you should present yourself. So nowadays people are actually expecting good communication, good clarity, understanding everything, right? So okay, so I don't have slides or anything today to discuss on, because this will be fully non-technical. Everyone is here only, right?
Yes.
Yeah. So I'll just start with like first thing first in the interview. What do you think? What people are? How it start? How the interview starts? The first thing first. Anybody?
Introduction.
Introduction, right? So in introduction, what kind of introduction people expect?
Our highest academic and also like the if we have some experience, they'll ask the projects that we have worked on. I mean, maybe that is, I mean, yeah, those are the parts that we have to include in self introduction.
Right. More than that, what it will be there in your resume, if you will find that you have already written your introduction, right? The very basic about yourself, everything. So one line summarize you need to do there, 1 or 2 line of summary, like 1 minute you can talk on your that thing, right? It's still people have already gone through your resume, so there should not be any mismatch between your introduction and whatever you have written in your resume, right? So whatever you are saying that in the resume and your conversation should not mismatch. Simple thing. Okay, that is one part. So how you will give the introduction? Like anybody want to start? How you will give the introduction? Oh, don't worry. See, this is not for judgment classes. I am not going to judge you guys. I never judge. I will judge you after once the training will be completed, right? After that, I will judge you how much you have taken. But right now, I'm not going to judge you. So don't worry for anything. Feel free to discuss. So the first thing for your interview, it should be you should not have fear. Feel free. Be confident, not overconfident. Not over, not under, but confident, right? And second part is like feel free. Like whenever you are in flow, you should be in flow, right? So what kind of things like generally it will be? Anybody?
Yeah, sir, I can give it a try.
Yeah. Please go ahead, Jitavir. Go ahead.
So first of all, I'll start with my introduction. Hello, good morning, sir. My name is Jataved Kambalimat. So I hold a bachelor's degree in electronics and communication, and as per my experience holds, I have a hands-on experience in PD flow, including floor plan, power plan, airdrop analysis, CTS, and routing. I've also worked on some timing reports and assisted with the STA team. And the projects that I've worked on includes 28 nanometer and 45 nanometer technologies. I've also exposure on synthesis, on routing, and also worked I also worked at the synthesis and also assisted my team.
Good. So this should be introduction. Make sure, Jitaved, whatever the point you said that, right? Floor plan, power, IR drop, whatever the synthesis, every topics you have taken, right? Now, after that, what will happen? They will go into these topics. This is where people start, right? So they will go, if good interviewers are there, right? They will go one by one. They will not break the, whatever the flow it is there. So they will not break it. So how they will go is, generally how I do, how like my team does is, once you started, right, floor plan, then I will go into the floor plan. What do you know about the floor plan? Like that I will ask you, right? So what do you know about the floor plan? Okay, not only Jataved, I'm expecting like everyone to say. Yoganand, Pooja, Rupesh, Arpita, Suresh, anyone?
Yes.
Yeah.
Yeah, floor
See,
planning is the
again, I'm telling you guys, feel free. Here, no one will judge you. Make yourself very comfortable. Let's discuss this. If some gaps are there, we can discuss and we can correct it out, right? But make sure that there should not be any gap in your interview, correct? Yeah, go ahead. Go ahead, Puja. Sorry.
Yeah, floor plan is the first step in PD flow. So in floor plan, we create a core area and die area. So the chip top may give us the coordinates, and based on that, we create a core area and die area. And the shape of the design is stored with a particular utilization. So so based on the utilization, we create the core area, and after that, we go for the port placement. Then we place the ports accordingly, and after the port placement, we go for some of the checks like if the ports are correctly placed or not. If the ports are not overlapping, and there should be some minimum spacing between the ports. So these all are the checks after the port placement. After the port placement, we go for the macro placement, and after the macro placement, the power planning is done. So these four steps come under the floor plan steps.
Correct. So how we discussed is like the first thing first we started with the this is not the first step that what you were talking about. This is like import design we does, right? So that we discussed the inputs, all the inputs we take. That is the first step, correct? So I'll just correct it out. Like it is good. I'll just correct it out. What all we can add here. So other than that, we actually create the rows, whatever the step one by one we discussed, right? Same thing you can discuss. We make the core size, right? That we take from the chip top, or like we create it according to our experiments, right? Two things. Second thing, we create the basic. We do the basic floor plans, like creating rows, creating placement blockages, everything that we do, right? And then after we go to the port placement. After port placement, we go to the macro placement, right? And after macro placement, we go to the physical cells placement, recap, power switch, tap cells, right? And then after we go for PG that we discussed, power ground, the PG stripe that we actually create the PG rails inside our design, right? That is the one. And then after we do place some isolation cells, level shifter cells, and then we go for the base DRC cleanup, right? So this is the isolation, level shifter, and the base DRC was remaining. Other than that, few other cells are also there that I was about to discuss with you guys. So this is what actually it does, right? So now once you will say that we do the port placement, we do the macro placement, we do the power switch, these things, right? Now they will go into this one. Like, what do you mean by what is the macro placement? What are the things that you do? What do you things you consider to place the macros, right? That will be in a flow, kind of. So anyone else want to discuss on that? What are the macro placement? What are the things we do?
So basically, micro placement, there are some guidelines to place the micro.
Correct.
So some of them are like we can place the micro by using hierarchy level, means that all the same logic of micro we can place at one place, or we can place micro by using fly lines and so that I think virtual connection, correct, sir? If I'm not wrong.
Okay, I will tell you. Always the way we discussed, right? Go point by point. It will be very clear for them. Okay.
Okay.
1, 2, 3, 4, like that. If you will go right, and you will explain the things, you will be clear. They will be clear. Second thing is like have always a copy and pen. What you are talking. If it is a virtual interview or like video interview, like or audio interview, have copy and pen. I always go to any discussion, any interview with a pen and paper. I never leave that. Okay, what it does is it will you can write there itself like number one this number two this like that. Go ahead, Rupesh. Like that you can do it. Okay, for everyone. Try to be best, right? You are spending your time, so try to be best in that particular interview. Yeah, go ahead.
Yeah, so by we can place the micro by using that fly lens also. Then after that, third one is we can place micro.
Go ahead.
Sorry, we cannot place micro nearby that input output ports, IO ports, and
Okay, go ahead. Anyone else? We discussed all these things, right?
Sir, I'll try, sir.
Yeah, yeah, go ahead.
Okay, sir. In floor plan, what we are going to start with is that we'll be having the design ready, means the layer core area. So we'll start with the macros. So once we are starting with the macros, we'll group the similar macros together. So we'll place first point is we'll place the similar macros group based. Uh, Sorry. We'll group the
Go.
similar macros together and we'll.
Don't be in hurry. People are not going to bang you here, right? Go
Okay.
in hurry. Just think. Think first, then talk.
Actually, I got a notification. I got distracted. Okay. Yes, sir. I'll continue.
Oh, why have question? Okay, think one thing. Like always, have some isolated room or something so that no one will come, nothing will happen, all your mobile is silent. See, these are the basic things that you should do before going to that, right? Go to washroom, get fresh, have something light to eat, have one water bottle, right? These things are basic things that we should do during like before interview or training or anything, right? Where you don't want yourself to get distracted.
Yes.
Okay?
Okay.
Chalo,
Yeah.
start.
So first point is we'll group similar macros based upon their hierarchies, means their families. So the first thing we'll do that. Then we'll do the flyline analysis. What we do in the flyline analysis is this: it will show the similar macros to be which are interacting with the pins. Also, based upon that, we can identify the macros and we can place similar macros together. So this will help in the first point also. And the third point is we'll make sure that macros are placed at edges, means core edges. So we don't make them placed in the center or anywhere so that it is blocking the pin ports or anything. And we'll make sure that these macros are accessible for the pins, and these macros are not placed in such a way that they are blocking pin ports and all. So the next point is we'll look into the orientation, means we'll make sure that the orientation is maintained without any crisscross or notches present in the block while designing. And then while placing, then we'll go with the spacing between macros. If there are two conditions, we'll have abutted and non-abutted. If we are having the pins accessibility and we have the feasibility of making an abutted design, we'll use the we'll abut the macros. If not, we'll give sufficient spacing and make sure that sufficient spacing is given so that the routing tracks are available in the next stages. Sufficient routing tracks can be made available to access the pins of macros in the next stages. We'll keep this in mind and we'll give the spacing to the macros, that is minimum spacing. Then we'll go with the pins, means the similar macros together, and we'll identify the communicating pins to with the ports, means the macros which are communicating with the similar ports will be placed together or one side. Then we'll start with the key port margins or halos. So that the macros are given sufficient key port margins or halos, so that we don't ensure that there will be, we don't want any congestion to be present in the next stages. We'll ensure that the key port margin and halos are present. Then that next point would be we'll make sure that the macro stacking is limited, so that we don't stack up lot of macros and create congestion in the next stages. Then we'll look for the macro placements so that they are fixed and they are not moved or not, they are not disturbed in the next stages. We'll make sure that they are fixed, and we'll look for the routing area to be reserved. As we discussed in the previous points, I'll make sure that the sufficient routing length or routing track area is assigned so that there is no congestion in the next stages. And we'll not place any of the macros completely near the pin or port area, so that it blocks the port area.
Okay, good. This is the detailed explanation actually people will be looking for. Okay. Thing is like, now what next? People will go into another point, right? Like whatever the point said, right? The port, it should not be near the port, notches should not be there, channels should be minimized, and we should try to block the channel according to the requirement of everything that we will discuss. Now people will ask you, what will happen if notches are there in the design? Why you are avoiding the notches? Any else? We discussed all these, right?
If notches we are not avoid means we face the congestion, means congestion in that congestions we face the routing congestion, and because of the routing congestion we face the shorts, and that shorts will be a PG shorts, signal shorts, clock these shorts are we are facing if notches we are
Okay.
not
So
covered.
so many standard cells, so many route will be going through that dot those notches, and hence it may cause congestion, right? That maybe we will not get the better routability in that particular area. Correct? Okay,
Yes.
good. So like that, people will ask you. Now again, people will ask you, what are the physical cells you were discussing, the boundary cap? What is boundary cap cells? Anyone?
Boundary cap cells are the which are placed at the boundary of the core area actually. Uh, it is also known as end cap cell actually, and we can to avoid
Yeah, go ahead.
yeah.
Anyone else? Charisma,
Sir.
Suraj.
Sir.
Go ahead, please.
Sir, actually, boundary cap cells are those which indicate the end of the row and start of the row that will be placed along the boundaries of the core area, so that these will ensure that the row placement row terminates or start, and this will ensure that the block is integrated, means we'll have these end cap cells present, so that this completes the row completely in the core area in the block, sir.
Correct. So, like, you can add few more points why we are using boundary capsules. What if we are not using boundary capsules?
Yes, sir. Sir, if we will
What will
not
happen?
bring the boundary cells, the DRC violations will come.
Correct. So, in will tie of connection, it should be there, right? The word I said. So that it
Yes,
should be
sir.
there. Okay, that is one point. Second point is, what is capsules? Or first, let's go one by one. Boundary cap, power switch cells. What is power switch cell? Let's go one by one. This will be, see, you guys are already trained. So I will, today we will discuss throughout physical design. Like this verbal discussion will happen today. Okay. What is power switch cells? As we discussed, right? Okay, I'll take the names. Okay, Rakesh, tell me what is boundary capsules? Sorry, power switch
Power
cells.
switch. Yeah, basically power switch cells are physical only cells. These are defined in the UPF file with respect to power domains, and also these are used to avoid the inrush current, like sudden current. If you want to block that, so we are using these power switch cells, and also we can ensure that standard cell won't get damaged with the inrush current. Yeah.
Hmm. Other points?
Sir, power switch wells are placed in the DC chain model. DC chain model, so that the power is supplied from bottom to top and left to right, so that there is no cells, means there is no left out of power switch cells in the design, sir.
Got it.
Also, it is having 4 pins, sir. So enable few, enable reset, awk few, awk reset. First two are inputs and last two are the first two are inputs and last two are outputs.
Okay. So yes, correct. So like that. So two input pins, two output pins. Whatever we discussed, right? This is why I say that create a node copy. I understand now that how it is difficult for Tejaswini, on Wednesday. So note it down everything. Don't lose out words. Second thing, once this power switch is done, right? What about the tap cells? What is tap cells? Why we are using? How we are using? Where we are using? Everything. Okay, I will ask one by one.
Sir,
Ashok, you will be there in the
sir,
last.
so well tapped cell, should I
Yes,
explain,
sir.
sir?
Go ahead,
Yes, sir.
Arpita. Go ahead,
Well
Arpita.
tapped cells are physical cells which is placed in the design to avoid the latch-up condition and maintain VDD and VSS annual continuity.
Continuity. This is correct. So, how we are using the well tap cells? How we are placing it?
Sir, like we can place near the standard cells so that continuity can be maintained.
So tap cell we can place in the core area by using checkboard fashion.
Sir,
Uh,
we can place the should be placed before the PG cell, PG grid insertion, and based on the pitch and width and in a column pattern.
why before PG only? See, these kind of questions in this way will come. So let's discuss on like this. Why before PG only?
Mm, So that sir, they the means we have to avoid the latch up now. So for, before the PG we place the so that cell can be placed in a continuity manner. If once latch up is avoided now, then PG will also come into the picture. Sir, I'm not clear about all these things, but we read that we have to place
Right.
this before the PG.
Correct. So this we
Towards the
discussed
latch up.
last week. Okay. This
Based
we
on the
discussed.
pitch with the offset in a column pattern.
Yeah, so this we discussed last week. What we discussed is we get a very good estimation, PG estimation, right? And that is where that good like whatever the estimation we do, right? Once all the physical cells, connectivity cells will be placed, right? Then we are good to go for all the PG stripes routing. So the estimation of PG will be better with this, correct?
Okay,
Okay.
sir.
Yeah. So once this is done, right? So from that, these are the things the physical. Whenever in the any topics comes, right? Boundary cap, power switch, or like tap cells, go ahead and say that that these are the physical cells. Okay. Start with that. This is a boundary cap cell. Is a physical cells. From there you started, right? And from there, after that, whatever the 3-4 points you have written, right? How you are placing, where you are placing, why we need that particular cell every time whenever any cell is there, right, or anywhere, why we need to place that particular cell, that you need to understand. Okay, so that don't forget to talk about that, right? That is one part. After that we have isolation cells. So anybody want to talk about isolation cells? Achha, Ashok, I asked you last question, you only go ahead for this one.
Yes, sir. Sir, so basically, that I know, like isolation cells, yeah, like are the cells which are like introduced in the power domain to like isolate the wires, buses and wires in the power domain.
Why only buses and wires? It's the entire logic group that we want to isolate it, right? So for
Yeah,
that,
that is not currently usable or.
yes, so it will be switchable domain, right? Whenever it is a switchable domain, what will happen is, see, be clear what we are discussing. So whatever way we are doing it, right? Cell, that particular logic, it is controlling. So how it is controlling signal, right? So I will not go into like deep dive into any topics. I will just give you the few points which you can, if you want, you can go ahead and talk on those few points. Okay. Okay.
Sir, your voice is breaking after some few minutes, sir.
Yes, sir. It's breaking.
It's
Is
continuously
it
breaking.
now? It is good.
Now it is good, but after
Give me,
10 to 15 seconds again it is breakable.
give me a moment. Yeah, is this fine now?
Yeah, now it's fine.
Yes, sir.
Yeah. Okay, got it. I know the issue, what the issue is. So, okay. Next, once the floor plan is done, right? After that, what is the next step for the physical design?
Placement.
Placement, right? So, what is the first thing we do in the placement?
Sir, first thing I think we will check like previous, like there are some checks before starting placement. We will do that.
Sanity checks, that is called as. So,
Yes.
those sanity checks, like what are the sanity checks that we do? Anybody?
Input output ports are placed in that fixed or not.
So like floating pins in the netlist,
Micro,
Correct.
micro,
unconstrained pin.
Placement of
is
that.
fixed or not.
Yes, correct. Correct. Anything else?
Or if all the macros are fixed or not.
How all the macros are fixed or not? This is
Idle
One more
buffers.
thing, micros are not overlap each other.
correct. That overlapping physical cells would not get overlapped, because now whatever the physical cells we have, right? If it is getting overlapped, it will be fixed, right? Like all the physical cells will be fixed. So what will happen whenever you have standard cells, right? It might. Just imagine your tap cells will is not sitting in that particular column. Your power switch is not sitting in that particular daisy chain, right? What will happen? So these are the things that we should look for. Okay. You were talking something, Rakesh?
No, sir, it's been covered actually. You already discussed.
Correct. So after that, what are the steps for the placement that we do? What are the different steps?
Basically, in the placement stage, we are doing global placement, which is nothing but course placement, then detail placement, then after that placement legalization, and yeah, that is.
Okay, so let's anybody want to discuss here? Because see, you guys are preparing for interview, so I actually want to listen from you. Today is not like I'm not going to deliver, so I want to understand from you guys, like what. So what will be the steps for the placement? Anybody?
Sir, to simplify the steps in placement, we'll just first start with the global route, sir. We'll make a global route.
Placement, global placement, not global route.
Sorry, global placement. Then
Then legalization.
yes, sir, legalization.
Then detailed placement, final placement.
Final placement,
Detailed
three.
placement and optimization. So basically, three steps are there in the placement, right? Remember, guys, like note it down if you want for your interview. Global placement, legalization, and the detailed placement. So global placement, again, people will ask you what is global placement, what is legalization, what is detailed placement, right? Just go into that. Okay. Now coming to the point, what are the quality checks for the placement?
So the congestion issue, legality, check timing,
Correct. Go one by one.
congestion, and
Congestion.
then check legality, check
Legality.
timing,
Okay.
logical DRCs,
Logical DRC or DRVs, perfect.
yeah, and IR drop analysis.
IR drop we don't do here. First understand what IR drop is, okay? So that we will discuss like after CTS how we are doing BRT. I will come to that point. I'm just revising you guys like what it should be. So let's go one by one. Congestion. What are the issues that you have faced till now? If you have done some projects, what are the congestion issues that you have fixed, and how did you get rid of that particular problem statement from the congestion point of view? Tell me. Anyone?
So cell density.
Deepa, you can talk. Okay. I asked Sanjay to like send you guys also. So if
Yes, sir.
you have something to discuss, and if you want to discuss or to ask something, today's session is totally based on the interview process. So ask, or like be a part of the discussion.
Yes, sir.
Yeah, sure. So, okay, go first. What are the issues like what I asked for the congestion? Yuvanand, you are totally silent today. What happened? Your mic is not working. Technical issues, something.
Sir, I tried to join, there's some issue with the mic, and also, hello,
Go ahead.
I have some issues with the mic, sir.
No
My
problem. You're gonna
is giving
keep
some sound.
practicing. Keep practicing things, okay?
Yeah, so I'll try to rejoin, sir.
No problem. Yeah, go ahead. Who wanted to answer that? The congestion. Any issue with respect to congestion you have faced till now?
Yes, sir. Once I saw
Hello.
like if
Yes.
many standard cells are placed at one position.
Uh-huh.
So to fix that, like I used blockage upon that area.
Block is on that particular area, correct?
Yes, sir.
Okay. What else?
So the another is standard cell. So my standard cell are the near about the macros. So I place them far than macros. So that is also a congestion. And some a congestion is of standard cell density in a limited area. So I place there a blockage, partial blockage. So for the removing the congestion.
Okay. So I'm sharing my screen. Okay. Visible, right?
Yes, sir.
Okay. Now see, this is your design. I will ask, like many people will give you board also. This is design, and these are the macros I have. Simple design. These are the macros I have placed it. Okay, these are the macros I have placed it. These some like this, some particular macros like this. This is one part. I have few ports here. I have few ports here from here to here. Okay. Now I will ask you the question. This will be the problem statement. How you will answer this? Let's make it practical. I'm getting the congestion in this particular area. I'm getting the congestion in, let's take the blue one. I'm getting the congestion in this particular area. What we will do here? What will be your analysis here, and what will be your debug? Simple. I'm just asking that question.
So basically, there might be an issue with respect to pin density. I mean, with respect to the port, I mean input and output ports, sir. So I might increase the distance between each and every pin, input pin, sir.
Okay, that is one question. Anything else? Think of it. Other people think of it. This is good. This is not bad. This is good. Anything else?
Sir, excuse me, I'm audible.
Yeah, audio. Go ahead.
So I'll see if the issues with cell density or pin density, but I'll use a partial blockage there.
Partial blockage, you put it the partial blockage here. Okay, so whenever people say that this is the problem, first understand what is the problem here. First understand what I will look for here is why congestion is there, right? I will not directly go to the conclusion that this will be the issue, right?
Yes.
Whenever someone will ask me that this area congestion is there, I will tell you my point of view, then you guys can tell me yours. Okay, my point of view will be why this area is congested. This area is having congestion. Okay, why this area is having congestion, that is one point. This will be my view. Okay, second, number one, second, I will look for what is the problem here, whether cell density or because of cell density, cause of cell density. I'm writing it here so that you can also write cell density. Cell density is the problem. What if it is there? Then what we will do? Third point is pointly, like things will be pointly. Second thing is because of ports, ports and logic connected to them. So right, so everything comes where? Mostly the cell density only, right? Both the point. So first thing first, what I will do is, first thing, why area, why congestion is there, that I will look for. So why congestion is in this particular area, whether because of this port routing, whatever the route it happens from here, and all ports are in like similar particular, like 1 meter layer only, like some M11 M10 only, right? If all are there, then we might use the alternate metal layer. Someone answered that, right? We can spread it, or like we can make the, if we are not spreading it, we don't have option, what we can do, like M10, or another one is M12, I can use M8, I can use other metal layers, I can use it, right? So that what will happen, same metal layer tracks will not be utilized, okay, here in this particular area. That is one point. Second point, if not because of this thing, because of the cell, that might also happen, and this might happen here also, anywhere in the design it might happen, right? So what will happen here is, if cell density is more, then what you will do here?
Cell spreading.
How you will do the cell spreading? How cell spreading will be done?
Partial blockage.
Placement blockage. Partial blockage.
Perfect. This is how you should answer. You should create things, right? This is good. Next thing is, this is our answer is done and dusted, correct? Now see, one by one we went, and how clarity the answer of this is. Now second is, if because of the port, what we will do? We will change the metal layers for the port connection, if because of the port it is happening. Clear for everyone, everything?
Yes, sir.
Yes, sir.
I'm just giving you few examples. This you can include that you have seen these kind of like issues in your projects, like that you can project there. Okay. Okay. Clear? Be very careful like what you are answering. Now, second point. That was the one thing. Second thing is, I'm getting somewhere in between. I'm getting the condition here. Now tell me, what will be your analysis? What will be your debug? What will be your solution? First thing is analysis, don't forget. And next thing is how you are debugging it, and what is your solution? ADS, like that. Analysis, debug, and the solution. So first, what will be your analysis here? What you will do?
Yeah, so first my step would be I will check whether, I mean, why a lot of cells are placed right at the cursor. I mean, I'll check if there are any other places in the layout where I can move the cells. So if the cells are placed very near to each other, and if the congestion, I mean, if there's a lot of congestion in the core, I'll make sure to add some blockages, so that some of the cells might go and place somewhere else, so that there'll be less congestion.
Correct. So this reason, any core reason other than that, what will be the reason? Mostly the cells will be the reason. What are the reasons? Mostly the cell density, whatever the bigger cells, like having more number of pins, right? Because of this more number of pins, what will happen? More number of pins, that means they need more routing tracks, correct?
Yes.
And more routing tracks, that means it will take more congestion. So mostly you will see in your design, registers, big registers where we do the multi-bit we discussed, right? So multi-bit, this whatever the multi-bit, they have more number of pins. AOI and or inverter, these are the bigger cells. What they does is they have more number of pins. So two things we can do. Either we can disintegrate these cells, right? We will m-bit we can disintegrate to the lower, like if it is 8-bit register, we can disintegrate it to 2-bit, or like 1-bit, like that we can disintegrate. This is point number 1. Point number 2, for the AOI, we can disintegrate to and the inverter, different cells, and they can be spread here and there, right? Now you will think the layout size. So layout size of AOI is this much, then might be the and or inverter will be like this, right? Small, and these will be having like pins, like 4, 5, 6 pins, right? So 1, 2, 3, like that it will be, the pins will be. So it will be distributed, two things. So now if this area congestion is coming, then first I will say, look for why the congestion is coming. What is the reason for the congestion in this area? So now, what will be the reason? Might be the cell density. So we'll look for that. If point number one, if cell density is there in this one also, point number one, if cell density is high, then simple answer will be what we did, partial blockage, right? Second thing, if not cell density, if I feel that there are bigger cells and the cell density is good, but the pin density is high, right? Pin density. Then what we will do here? Pin density. What we will do here?
We will integrate.
Disintegrate.
Disintegrate.
Integrate the cells so that the pins will be distributed. Like AOI having these many input pins, it will be disintegrated in smaller cells. Clear?
Yes, sir.
Yes, sir.
This is 2 point. Third point here, what we can do is, if we cannot disintegrate, then we will use keep out margin here. Keep out margin. Note it down. Keep out margin. So one scenario I gave you like this. These I have not included in PPT also. I'm just telling day by day what I'm having, the situations, okay? The practical situations I'm giving you. This scenario number 2. This is scenario number 1. I told you this is scenario number 2, right? This is the practical one. Now, under one, cell density is high. What we will do? Partial blockage. Pin density is high, we will disintegrate. And other than that, if we cannot disintegrate, many times it will be required that you have some power numbers, that if you are doing multi-bit disintegration, your power might go down, right? Power number might shoot up. So in that case, we can make the keep out margin, right? Note it down quickly, be fast. Be like these guys, right? News agency. What is that?
Noted, sir. Noted.
Noted, right?
Yeah.
Note it down. So point wisely, this is the 2 scenario, right? Third scenario, what it might be, just understand it. There are few more. I have one macro here, right, and another macro here. Right? Now I'm getting congestion in this area. I'll change the color. I'm getting congestion in this area. So here, what is the reason?
Notch.
Notch is the reason, right? So in this reason, what we can do? What all we can do here?
Partial blockages.
Acha, again, before going to that, you need to explain your analysis first, okay? Rather than jumping to solution. This is what everyone does in the interview. So first, why the congestion is coming in this area. Believe me, your interview will be going very good. You will be able to crack interview in one shot. So first analysis, why is coming in this area? Look around. Tell me one line that why congestion is coming in this area. Anybody? Why? I see many people are silent. Why? You don't want to go for interview?
Sir, like there can be many pins coming out there, so might be less routing resources available.
So for everyone, I'm just asking, like, be a part of discussion. Why I'm telling you to be the part of discussion? And I mean, your mic should not get unmuted. Okay, it should not be muted. You keep answering the questions. Nutan, I have not heard anything from you. For Ravalika Bandi, I have not heard anything from you guys. So I'm Srikant, I have not heard anything from you guys. Why I'm asking you guys to be a part of discussion? If you are talking something, you will remember during your interview also, right? See, today I wanted to complete placement, half of the placement, or what is at least the basics of the placement I wanted to complete. But I'm just, again, I will be delayed by 1 week, but that is okay. This is for you guys only, right? So understand, be part of the discussion. Okay. Okay. Now coming to that, where were we? First, tell me what Ashok. What was it? First.
So, like if there are many pins originating from this area, so there can be less routing resources.
Because of the pin density is high in that particular area. That might be one reason. Okay, a pin density.
Sir,
For
voice
that,
is
what you
breaking,
will
sir.
do?
Voice is
My voice is breaking.
Sir, it's very breaking, sir. Not audible, sir.
Now it is audible.
yes, sir. Yes.
Yeah, yes, sir.
It is pin density. What will happen?
Same, sir. We can distinct that
Disintegrate, sir.
disintegrate.
No, but that is not the bigger cells, right? If I'll say that I have very small cells in this particular area, then what you will do? Think of it.
Sir, we can put the blockages.
Yes, blockage is the last option that definitely we are going to do that. So partial blockage we can use in this area, right? We can have the 50% block or 60% block like that, right? Okay, what else?
Is it okay if we go back one stage
Always,
in floor plan?
I always said that first analysis I want to hear.
Sir, is it okay that we go back one stage and change the floor plan?
How you will change the floor plan?
No, is it okay? I'm just asking. Is it okay if we go back one stage and change the floor plan so that we'll not get a notch in first place?
See, this is your decision.
Yes.
Whatever the options it is there, right? Try it. Think of it.
We can reduce the stack macros.
How you will reduce that?
We can arrange the other macros in other place by reducing the whatever the height of the macro is.
Yes, good point, Naveen. So this you can exchange with this map. What is that? So this, if you will exchange this, think what will happen. This will come till here. This will come till here. What will happen? This notch will be gone, and after this will go here. So now this is a continuous process for all the code side. It will be there, right? This will be your code to basically place for. This is another good point. So point number 2 will be we can change the floor plan, right? We can rearrange the macros. Whatever the pin density you guys are saying, right? Pin density might not be the reason in this particular area. Tell me why. Why not? Reason is you have limited resources in this particular area, limited tracks, right? And you have all the macro pins also getting connected from here, right? So pin density is not the concern here. Pin density will be the concern where your cells, so many pins are coming and sitting in one particular area, right? So here macro pins are distributed, all distributed, small cells are there. If I'll say that, if bigger cells are there, then definitely a pin density. But smaller cells are there, what you will do? We can spread it out. We can put the partial blockages. What? Right? Someone said that answer, partial blockage. But first understand what are the reasons it is there, why it is there, right? Best option, what I will do is the floor plan change, what Naveen said. Okay? Point number 2. Okay, this is one point. Now, what is the reason that I am getting the congestion in this particular channel? What is the reason?
Insufficient routing resources. And routing tracks are insufficient actually.
Routing track are insufficient. That is true. That is your analysis. What is your solution on this one? Good.
I'll increase the channel width in such a way that we'll get more tracks available.
You don't have channel width, whatever the macros it is coming. If I will say that, if I will be interviewer, I will tell you that you don't have channel width. So this is the best macro, it is intact. What you will do here now?
I'll try to route in higher metal layers if possible.
Why higher metal layers? Why higher metal layers?
Well, wherever there are tracks available in whichever metal layer, I'll try to route them.
Think one thing, like that is possible. That is one possible. But think here, why your all channels are good, only this channel is like this. Why?
Micro placement is not good. That's why.
No, don't just blindly say that. Whatever the channel it is there, right? We should open only as per our requirement. So if congestion is there, we can block little bit more here, right? If till now here it is blocking, we can block till here also. Correct. So your answer analysis would be, since the area is not sufficient to route all the standard cells, so we will try to block more standard cells in that particular area, that particular channel.
Yes, I'll try to place soft blockages.
Soft blockages for only for the DRVs and all these clock tron, MPW or data tron, like that we will do. Correct.
Yeah.
So these are the different conditions. There are so many condition points. I just gave you 1, 2, 3, 4 like that, so that whenever they are asking like any issues that you have found through congestion, you can discuss one of these. Okay, that this was the reason. Now I'm giving you 5 minutes. Summarize things from the congestion point of view. Note it down in your notepad. Okay, go ahead.
So, sir, basically we do global route congestion analysis and placement congestion analysis, both of them, right?
Now come again.
So we do global route congestion analysis and placement congestion analysis, both.
Correct. See, two things are there. One is the congestion means congestion, right? If you are going to any, it's a crowd. Simple congestion. Another word you can say is the crowd. Synonyms, that what we call it. So that crowd, what does that mean? That means it might be because of cell, it might be because of route, but at the end you have to calculate your routing. So end of the day, that will be global route congestion. Okay. Now it depends on your interviewer what he is looking for. So be clear with that, like what he is actually looking for. Correct.
Yes, sir.
Go ahead.
Also,
Next.
I have a doubt with the placement flow, sir. So where do you perform high fan out synthesis?
Come again, your voice is very low.
Sir, is it audible now?
Now audible, tell me.
So where do we perform HFNS?
High fan out synthesis. See, that starts from the synthesis itself. We discussed, right?
Yeah, but physically, where do we do it? In the flow, in the part of flow?
No, part of flow. Where, like, what during the placement we do?
Yeah, actually, initially during placement we do HFNS, no, sir. Some flows mentioned that we do that in H. I mean, I personally did. I mean, when training project, sir, there HFNS has it has taken place during placement. I mean, initial stage of placement.
Correct. See, that's what I'm telling. It happens now. Physical synthesis, what it does? It does the placement. That's what we discussed.
Yes.
So during the start, it will start from physical synthesis. Similar thing it will try to do. Now next topic is that one only. We are coming to that. Wait. Okay. Let's write it down. Whatever we discussed. Done. We'll discuss. We'll go to the next topic then.
Yeah.
Everyone just say that yes.
Sir.
Yes, sir.
Sir, I had one thing like to ask. So, sir, basically in congestion, like once I read somewhere, like there was some issue nearby the feed through port also.
Feed through port, correct.
So what I read, like they solved it by like swapping the blocks, I guess. So the congestion got reduced, but at that time I didn't got that clearly.
Swapping the blocks means what? And
so like there was no crisscross path was forming between the feed through port somewhat like that.
Like 2 days back, I have also given one solution on this thing to my team. They were also facing. I will tell you that example what it is happening.
So basically, what is feed through ports actually means?
Good question. We have to discuss lots of things. Okay, it's just okay. I'll tell you what is feed through also. We have so many things to discuss. Give me a moment. Once you guys are done, let me know.
Yeah.
Yes, sir, completed.
Completed, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Um, I'm going to whatever Ashok has asked, and now Rupesh has asked. Give me a moment. I have taken your Sunday, right?
No, sir. It is good actually.
No, sir, it is the opposite. Opposite, sir. We have taken your Sunday.
Okay, so yesterday I had something got urgent medical things from my family, so I had to actually go yesterday. That is one point. Second point is like today also I had some work, but again, like one day I want to spend with you guys. That is where I thought like no, we'll prioritize the things accordingly. Okay, so since you guys are here, so let's make it the most. Okay, I'm sharing my screen again. Okay, so here I'll tell you one SOC is there. Just to answer your question first, Rupesh, what the feed through is. So nowadays, what is happening is one partition is here, another will be averted partition. Okay, averted partition. Let me take some other color here, some other color. Okay, some green I took. Okay. I'll just take one example. Actually, tell me one thing. This budgeting we discussed during synthesis.
No.
Timing budgeting.
No.
No one reminded me to do that. Okay, we'll do it during the TA session. Remind me if I forget. Topics remind me. We can discuss anytime. Okay.
Yeah.
Whenever I just take a note on the PPT, I don't create much slides. Fancy slides. I believe that on the groundwork, whatever we do, right, that actually help us rather than slides. Slides, what you will do? You will keep it in your drive, Google Drive. That's it. So I want to discuss the things in a way so that it will be in your drive, your actual drive. Okay, now coming to this one, what happens here is earlier days what was happening is for everyone just think be here. This is one SOC. Okay, this is one SOC, system on chip. This is going for the tip out, final tip out. This SOC, what it does is like this will be the small chips like this might be your from in different companies like right for different CPU companies like Intel or like AMD, from graphics NVIDIA, Intel, AMD, or like from the Snapdragon or like mobile processors from MediaTek and the Qualcomm, right? For AI ARM processor, right? So different companies. For TI also they have different, for ST and the NXP automotive industry, right? So majority of these chips are there in the industry. Final chip is going like this only, correct? Now internal to that they have different sub partitions, subsystems. One will be like your some CPU, GPU. Internal to that, video, camera, different subsystems. It will be there, right? On earlier days, what it used to do is like they had some spaces in between, okay, and then there was a full chip PNR that people used to do. So it was very less number, like not in the, like so many cells, not so high frequency, not so power dedicated things, right? It was happening. It was going good. It was going okay. When we came down to the lower technology nodes, I was talking about 2845 like that. When we came down to 10, 12, 15, right? And this 7 nanometer 5.3, there it has started happening is full chip. If some cells are there, it was very difficult to meet them for the timing with respect to this partition, and some cells are here in between, right? Some cells is here, right? Coming from here to here to going here. Instead of that, what people does is now this cell they have kept in one of these partitions itself, okay? And they made this design abated. Abated means what? Abated we discussed, right? Abated means one after another.
Yes,
There is not be any gap, right? So this they did it. Now understand what is happening. This is subsystem number 1. Understand this is camera. This is video. Okay, video. In between, what I have is a sensor. Some sensor is there. Understand what will happen. Camera need the video, right? Whenever we are switching on the camera, I'm just giving a typical example. So camera needs video, correct?
Yes, sir.
Yes, sir.
Few logics will be sitting here, which is interacting with here, right? This is interacting with here. But I don't have any logic in for this sensor between these two. I don't have any logic. Okay. For these parts, what we will do is, I don't have anything. So it will be a port for this sensor. It will be a port here and no logic sitting in between, because logics are here and here. There will not be any logic in between here. For these cells, so what we do is, we made a port placement like that and the buffering. Why buffering? I will come to the next point. But the port placement we do in a way that port will start from here and here. The logic will, whatever the logic it is coming here, it will come here. Okay. And in that way, what will happen? If it is coming here, this entire design will be actually making a way for this logic to go from this place to this place. That's it. No logic in between. These ports are called as feed through ports. Okay. And feed through means no logics in between. There will not be any logics. But the only thing is here, it is just helping us to pass the information, pass the logic from here to there. That is why we don't, if the sensor was not there, we would have put some logic here for this logic here. We would have done that in that way. But now what? We just need to pass it. Now understand, this is some 2K distance is there, 2K micron distance is there from here to here. What will happen if net is passing from here to here? What will happen to the net? The subsystem block size is more, right? What will happen?
Yes, sir. It will be a long net, so I think timing.
Yes, long net. We have violation. Yes, long net means no, don't jump to tran violations first. Long net means what will happen?
It means resistance will be high.
R will be mostly high. Will be high. Then tran. Now come to the tran. Tran will be high. If
the delay will be high. Delay will be high.
Like this, go one by one. In interview also, don't jump directly to the tran. People will be happy to listen like this. Okay. See, you guys knows things, but it's just that you need to align like this. So what happens here is that for that tran, we do buffering, right? Buffering here. That is called as feed through buffering. You might have heard the word. So this is what we do. Now understand, this is normal. If it is because of power domain, one power domain is this side also, then here also a channel of power domain you will have to create. Okay, that power domain channel will be having always on these, always on cells or like A on cells, right? That cells will be there, those buffering it will be there. A on cells we need to, now after this floor plan, right? I have taken the cells that we need to discuss. So it will be there, right? From here to here, this point. So this is what the feed through concept is, and this is how we actually take care of the feed through. Now, what was your question, Ashok?
Sir, like on the edge, like in the picture itself, it was showing on the corner edge, top right edge, there were two blocks, but the blocks were communicating like in a crisscross path.
That is another point. So this, that's what I told you, right? 2 days back, I show. So what is happening is like, let's take these two partitions, okay? One partition is here, another partition is here, okay? What is happening? So path, your one cell is sitting here, okay? Start point for this cell. End point is sitting here, right? Like just understand after this, if one partition is here, right? So your start point is here, this start point, and your end point is here, not straight. What it will happen? Either for this one it is fine, might be coming like this and then going like this, right? Unnecessarily you are wasting this much time. That is part one. Second part, what it will happen, this partition itself, it will be very crisscross, like going like this, coming like this, then reaching here, right? So feed through cells are not one or two cells. I will tell you again. It will be like 20K, 40K, like that logics are going from here to there. So imagine 20K cells are going like this crisscross. What will happen? Your this entire region, this region will be congested, right? So this is what it happens. So what we have to do is either place this cell this side or place this cell this side, so that it will be aligned, because we know, right, where the cell it should be, where that particular placement should be. That is why I always say, if your placement is good, your next stage will be better. If your placement is not good, your next stage will be very bad. So like floor plan, this is the first stage where your it should be very good quality. If your floor plan is not good, your placement will not be good, then your CTS will not be good, your route will not be good. Okay. Now, if your floor plan is correct, then your placement will be correct, CTS will be correct, route will be correct. So floor plan start from here, then placement should be proper, good. CTS, then it will be lesser. So basically, we need to spend more time here, right? And then here at the end.
Excuse me, sir.
Yeah.
Sir, how can we ensure our floor plan is good?
Yeah, so that you know, right? The congestion, we discussed one thing, that how
Yes, sir.
it has given you the results. Second thing we are going to discuss now is the DR. What Pooja said, that weird logical DRCs we are going to check. Third thing what we are going to check is the timing. Fourth thing what we are going to check is the power. So these are the things one by one. It will tell you what to do with the floor plan. Floor plan will be an iterative process. Come to the placement. Your placement is not so perfect. Go back to the floor plan.
Floor plan.
Okay.
Sir, that means without any placement, we can't say that floor plan is good or bad. Means
That depends on what quality of, yes, that depends on what quality of engineer you are. That will create that much. Few people takes 50 iterations, few people takes 20 iterations, few people takes 10 iterations. So this depends on your quality, how you are creating the floor plan. How, this is where we discussed, right? During the macro placement, we discussed almost 17, 18 ways, right? Rules. Why did we discuss that? Clear?
yes.
So this depends on you, how best you can make it. Yes, I will tell you. Few designs are very complex that definitely need some 40 iterations, 50 iterations like that. That is not a bad thing. That is not a bad thing. That shows that your design complexity is very high. But if I'm able to do it in 40 iterations, someone is able to do it in 100 iterations, right? Then depends on these quality of these two engineers, right? Among you only, there are 20 peoples now, 22 peoples. See the answers, right? Whenever you guys are discussing, you can see here, like how people are going to tell you or how people are silent. That can tell you that, you know, what quality you have, right? So you can judge yourself in that way, that what quality you are having, what the way you should improve. So definitely that is where, why this much rigorous process of interview. They want to check the quality of yours, right? That is where. So this definitely depends on your quality. If I'm doing the macro placement, right? The example I told you here, that one is a small macro, another one is big macro. In one time only, first time only, if I'll realize, hey, what will happen if I will place here, if I'll swap this macro from here to here and here to here. People will, what if you are thinking now only, proactively, your iterations will be less, right? Both points are clear?
Yes, sir.
Yes, sir.
Yeah. It should,
Yes,
Yes, sir.
design is complex. It might take more iterations. That is not a bad thing. That is not at all a bad thing. I will tell you, in Qualcomm also, people were not able to converse the design, few designs, like it was there, right? took some iterations, I was able to converge it. So that is the way, like, you should analyze, you should debug. That is where I always come first is the analysis, debug. So there, then come to the solution. This I will do. Don't directly jump to the solution. This is a habit of ours. Like, I also generally, when I will be lazy, I will directly jump to the solution. When I will be in a fresh mood, right, I will go first for the analysis. Even though I know the solution, still I will see that what is actually going on. That directly jumping to the solution, what I can think is, like, if I'm going for analysis, I might be able to think some other ways also. Be the best. That's it. That's what I wanted to tell you guys. Right? Floor plan will tell you, but how you were doing the floor plan first time, then only you can come to the placement. Then it will give you the quality. Right? Correct. If your placement is correct or not, how you will get to know? With the quality checks only. So this is what the quality checks is: congestion, DRVs, timing, power. How well the optimization you have done it. Okay? Clear?
Yes.
Yes, sir.
Yes, sir.
Think every time. Think like what best you can do. Think every time. We sometimes, I just, be silent, just thinking like, okay, this is going on, this I should do. Every time I do, like, day only, if you will ask me, right, at least an hour I spend on, being in, like, which people call like me time, right? Me time. So I usually go and I sit silently, okay, what I should do for this one. Even while walking also, but I will be isolated. I will not be with anyone. No phone will be in silent. Those particular time I actually utilize to understand myself, where I'm lagging. Okay? It's not that I'm not the perfect person. I'm also lagging anywhere. But I usually try to give my best, right? Every day. Okay? Not go ahead.
Sir, I have a doubt regarding the quality checks.
Go ahead, Naveen.
Sir, in real-time scenario, in particular stage, the engineer is coming across what is the maximum number of quality checks with respect to the floor plan or placement? What is the particular number? Can we go? That is my doubt.
No. So Naveen, we are here to discuss on all the quality checks, right? So don't worry. Like, once your everything will be done, right, then you will only tell me what is the quality checks that you need to do. Don't worry for that. Okay. After placement, I will only ask you what are the quality checks that you need to do. You will tell me point by point. So your doubt will be clear at that point. We have not yet reached. This is just for the interview process. I'm discussing. I'm going beyond my topics, whatever I have not discussed also. Okay. Next, coming to the DRC, logical DRCs and DRV. Who will start with? I don't want to take names. Go ahead. Number one. We have already discussed this. Number one.
Max time.
Max transition. Okay. Max transition. Number two.
Max capacitance.
Max fan out.
Okay. And third one is
Max fan out.
So you guys discussed about the max things, right? I will tell you here there is a min also. Okay. There is a min also, that also we will discuss. So this is good. Like, max is a limit that we, there is a min limit also. That also we need no min limit for fan out. Fan out should be the one is also fine.
So one is also net length.
Net length, yes, that is also correct. That it comes in the routability, but it's good. Whenever you say that, many people actually take this as a input. So this is good, no problem. But net length generally it comes in the routability, global route. So these also comes in the global route only, but this is the direct effect of the global route, net length. And now I will tell you, this will not be a part of this one, but I will tell you that how net length is actually basically affecting all these. So that I will come to. This is not a logical DRC. Like, if someone is telling it comes under logical DRC, After 5 minutes, you will only tell me that how that it is affecting the logical DRC. So it is not part of that, right? Now coming to the part, what is max transition? What is the transition? What is slew?
Transitions are like taking like how much time it is taking to change its logic from 0 to 1 or 1 to 0.
1 to 0, perfect answer, simple, right?
Yes.
See, for rise it has taken some 0 to 1 and from 1 to 0, right? Correct? Rupesh, you have any other answer?
Yes, sir. Yes, sir.
Yeah. Go ahead.
Yes, sir. Go ahead. Yeah.
No, Rupesh, you have any other answer? You were saying something.
No. I'm saying yes, correct.
Yeah, okay. Okay. So this is what we have, right? From 0 to 1. Transition means what? It is a changing the levels from 0 to 1, 1 to 0, right? Now, what are the factors that it is affecting the transition? What are the factors it is affecting from 0 to 1, 1 to 0? Simple thing. Let's discuss like this. Then we'll come to the conclusions, like, what are the solutions we should have it. So, what are the factors it is affecting from 0 to 1, 1 to 0?
More wire length.
Charging time of the capacitor and discharging time of the capacitor.
Yes, so now understand, this is a very basic from the RC network, that this we have discussed it during the synthesis time, that there is a charging time and a discharging time. Charging times, that means it is charging from 0 to 1, discharging means 1 to 0, right? So that time will be time that is some E0 into what it will be, the calculation, that whatever this formula, whenever people comes for the RC circuit, right, definitely talk this formula, say that this is a formula, e to the power minus T by RC. Okay, how should I write here? Okay, so let me draw it here itself. Okay,
E to the power something, yeah?
So 1 minus e to the power minus T by RC, like this it is coming, right? This is coming, some value T naught time equals to like this. This is for charging. This is for discharging. For discharging, what we do? T naught 1 minus e to the power minus T by RC. Okay, minus T by RC. Note it down. So this is the basic formula what we discussed in the RC second, third semester, right? There we have learned this. This, if you will see, right, the output of this one will be like this, and this will be whatever it is coming, like 1 e to the power, like this, right? So this basically decides how your graph will go from 1 to 0 to 1, charge will happen, and this will decide how the discharge will happen. This we will discuss again, but just to give you overview, I'm telling you this one, note it down, just to for your interview purpose, right? So after that, what happens? This RC basically, right? 1 minus T1, whatever it is getting having from this calculation you see, right? RC value, if it is high, what will happen? 1 by e to the power minus 1 by T to the power RC, right? It will be correct. So whatever the value it will be deducting from 1, right? It will be more, right? Similarly for e to the power minus T by RC. So I'm not going deep into your RC circuit. Think of it, what you have learned and revise of it. Now going forward here, if your transition, now this RC, basically we got it, how it is charging and getting discharged, right? These two formula. Why that now point is, why RC will increase? Why RC will increase? What are the reasons that RC will increase? That this is going bad. If RC is increasing, this is going bad, right? So why RC will be bad? What are the reasons?
Net length is
high. So this is what the net length. If someone has told you that net length also come in a part of this one, right? I don't know why, but this is actually affecting everything. So net length is your first thing, right? Net length. If net length increases, RC increases. Number 2, what?
delay increases.
Hey, I'm not going to. I'm RC. Why
Okay, sorry.
We will go to the delay also. Why RC? Because of net length. Why net length? More length, more R, right? Then RC will be more. What else?
Fan out, high fan out.
High fan out. Fan out, I will come to that one. Transition we are discussing right now.
Low drive strength of the driver.
Low drive strength of the driver. What it will happen with the low drive strength of the driver? What is happening here? Like I have, it is driving some 4 cells. Some 4 cells, just understand this. It is driving some 4 cells. What will happen here?
Delay increases.
Sir, it will take more time to drive.
Yes. Why it is taking more time? More time means delay has increased, right? But why it is? This is a fan out example. One is here, simple. Is it simple here? What is happening here is one cell is there, 1x drive strength. This we discussed it, right? This is 8x drive strength. This 1x is driving 8x. Okay. What is happening here? Why the tran is high here? Okay. Why the RC is high here?
The input capacitance of 8x is high.
Input of 8x is high, correct. So input of 8x is high, like we can make it as 8C, correct?
Yes,
like that, imagine. And this is C, right? So C. So what will be the final capacitance at the output?
9C.
Here. 9C, right? So this C has increased here, right? So one is net length, one is driver, this one. So C has increased, that overall RC has increased. So that is where low drive strength. So whenever, like I think Ashok, you said, right, low drive strength.
Yoganand, sir.
Yoganand. So you should understand, Yoganand, like why this 1x drive strength, what is the problem here? Okay, I know you know the answer, but you don't know the logic. So this is where you need to make them understand what is the logic. Okay, this is one point. Second point, any other point? Any other point? I'll take out flash the PPT. Okay. Any other point? Think white tran is there. White tran. Simple. White tran. Global placement, scan chain reordering, scan def. Think why? Now again I'm sharing my screen. Think why?
Sir, insufficient power delivery.
What is that? This was point number 1, that net length. This was point number 2, low drive strength. Go ahead, see, no one will judge you here. See, I will tell you again, I generally don't judge people.
It will consume more power?
Power we are not talking about. RC we are talking, why RC is more. That means it is affecting this tran. From where we have come? From this RC equation, right? One by one we will go. This, because of this reason, tran is getting good or violated. Depends on which factor? RC factor. Now, if RC is more, then your tran will be bad. It will be going like this. Why? What are the reasons that your RC might be more? R we got it. C we got it. Any other reason that R is increasing or C is increasing? Any other reason?
Oh, so temperature might be. Temperature, sir?
Come again?
Temperature?
This is not PVT we are talking about. This is not PBT we are talking about. Before saying think once, what is the meaning of? Okay, what are the things? Okay, now tell me the third example. So these two you got it. You guys got it, right?
Sir, can
I'm
we
expecting from you guys.
crosstalk here?
Okay, let's not talk about crosstalk here. Actually, I'm expecting that you guys, all of you have got trained, right? And if you are coming with theoretical knowledge, people will literally crush, like, that one after another questions will come. And people might. So this is why I always come like this. I always come like this. And one after another, go. If you don't have clarity, then believe me, you don't have concept. So right now, for interview, don't think like that. Go ahead with whatever the concept you know. We will discuss everything onwards. But right now, try to understand whatever the topic I am going to discuss. Imagine for one people you are going, right? They are asking more on this tron. You can explain everything like this. They are asking more on congestion. You can explain all the 4 points we discussed. Then your interview will be at very good point. Okay. So think again, RC. We already discussed about the metal layers. M0 or M1 to M14. M14. Which one will be having high resistance?
M0.
Huh?
M0.
This is M1 and this is M14. Which one will be having
M1?
M1. Why?
M1 sensor.
Because it will have less width when compared to M14.
Sir, width of the M14 will be wider than M1.
Rho L by A is the resistance, right? Rho L by A. So whatever the M1 is there, right? This is there for that particular, and that is actually creating it. So whenever it comes to resistance capacitance, go into this mode, epsilon A by D and the rho L by A. Always don't forget, these are the basic formulas. Now also I actually think like this only. Okay, I will tell you how this factor, how this actually lead to your crosstalk, right? This actually lead to your high resistance capacitance, right? So this is what it is, right? Now, if metal layer is different, then we need to promote it to higher metal layer. So lower metal layer. Point number D. What it will happen in the same metal layer? If length is this, we have discussed this length. First point is what? Net length L. Correct? This is what it is, correct?
Yes.
Net length, what we are discussing. See how it is directly proportional. So net length is high, that means resistance will be high. Resistance is high, total RC will be high. Simple. Now, what about that particular area? Area is high. Then what will happen? Your resistance will decrease. Area is less. Then your resistance will be high. So if that particular metal layer area is less, then your RC will be high. Clear?
Yes, sir.
Yes, sir.
Now, actually, if I will be your interviewer, I will expect in this way. Okay? Think like this. Why? Note it down quickly. Note it down. This I should not forget also. One is net length. Down quickly. And one is net length. Number two is low dry strength cells. Number three is lower metal layer. Number four is less area. Less metal area of same metal. Okay. That calculation it will be there. Correct? Now think. If I go to PPT, I also feel like I'm bounded. I mean, whenever I come to discussion like this, I feel like I can discuss anything here. So one after another, one after another. Okay, clear, guys? This one. Anybody is having any doubt in this one?
No, sir. Now I'm getting if you answer differently means interviewer ask go to that point only.
Correct. Correct. So this is how you should be clear and confident. Okay. There are so many timings we have not come, right? Timing analysis is like way good, way better, like we should do. People generally don't understand how to analyze the timing.
Sir, I had one doubt actually, sir. Means regarding the dev file. I have yesterday revising the dev file as you told that in the dev file you are giving some scenario, 3 to 4 scenario. So while I am in the project, those people are doing some 1x reduction, 2x reduction in the dev file actually.
Reduction of 4 area.
Yeah. So while doing the practical session, can you teach us that how to do that?
That this guy just now I got a ping, right?
Yeah.
I have gave him like 3.4 micron is one in 2y, right? So 2y, I actually I had literally a very good fight with the management last Friday, and we got some extra area for our partition. This guy was literally struggling, right? So that we have hacked it, and then we had to do the port placement also, right? So that we did. So this is not a very big thing that we can discuss. Okay. This is good. Let me complete this topic, Rupesh. After that, we'll go.
Yeah. No problem, sir. I'm saying that while doing practical session that time only, not right now.
That time, like I will try to tweak as much I can your designs, and I will try to write the scripts as much I can. I will ask you to write. No, I'm not writing anything for you guys. I will ask you guys only to write the scripts in the practical sessions. I'm also actually waiting for that part only. That is actually even more interactive, right? So I'm deleting this one. Okay, this side I will utilize it for some others. Okay, so this I can delete it, right?
Yes, sir. Yes, sir.
Uh-huh. Coming to the max transition, we got it like 4 control Z. Okay. First one was the net length, let it be here. Okay, now understand. Now we got the analysis, we got our analysis. So our analysis is done, analysis debug is done, right? Now it's coming to the solution. If net length is high, what you will do? Go ahead, fatafat. Net length is high, what you will do?
We will add buffers.
Pull the cells closer.
If net length is this much, right? We can add one buffer in between. Correct? Simple. Very simple.
Yes, sir.
No need to discuss on this one. Second one is what? Second one was what? Load rise strength cells. What you will do here?
Upsize this rise strength.
Correct. We will upsize it to some particular 4x or 8x almost. Okay? We'll try to do that. We'll see how the tron is coming. Number third. What is their third? Lower metal layer. Lower metal layer, what we will do? If it is in M1, what we will do?
We will move to high metal layers.
Higher.
M8, where we get the better transition, M10, M12, wherever we find that it is giving better transition, we'll move it to that particular layer. Correct? Fourth thing, what we have is, what was the fourth? Area.
Area is less.
Yeah, we can increase the area. How we will increase the area? Area equals to length and the whatever this metal layer is there, this particular area is there, right? This particular, we will increase the area by 2x. That is also called as NDR, non-default rule, that we will discuss during the CTS. So we will increase the area. After increasing the area, what it will happen? Our tran will be better. So this is number point D. Correct? Simple. See how much time it took for us to get the solution?
Yes, sir.
2 minutes, not more than that. How much time it took for analysis? 10 minutes?
Yes.
And this will be your perfect result. Always perfect result. So I always go analysis, debug, then solution. Don't directly jump to the solution. Okay? Clear?
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
Okay. Chalo.
Yes,
This is
sir.
how you will explain in the interview also. I'm expecting. And if believe me, if you are explaining like this, people will not have answer. Okay. Coming to the next point of the transition, there are two types of transition. How many types of routes are there in the design? One, two, three. Quickly, quickly. First route.
Power route.
Hey, PG. I will PG. Second is
Clock.
third is data. So there is no transition for PZ, power stripes. Transition for clock, it will be there, data, it will be there. Right? So these two, clock transition, data transition, we call it as. Correct? Clear?
Yes, sir.
Yes, sir.
Note it down fatafat,
Yeah.
quickly.
Yes, yes.
Quickly note it down. Quickly note it down. Now, coming to next point, capacitance. We discussed capacitance also, right? Similar thing, capacitance. Now, max fan out. This is the third point we will discuss. So, one buffer, or like any resistor is there, buffer is there, any cell output. 1, 2, 3, 4, like this. Understand this is 100 cells are there in like this. Okay, 100 cells are there. Understand now. You guys are here or writing? Go ahead, write it down first.
Done, sir.
Done,
Write
sir.
it down quickly.
Done, sir.
Done, sir.
Done, sir.
Done? Everyone?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Tell me, no one is lagging behind, correct? I'm actually thinking that if you are not talking also, I'm thinking that some people are introvert, right? They don't want to talk, but they understand everything. So I'm thinking in that way, Srikant, Suraj, I don't hear from you.
Yeah,
Uh,
done, sir.
correct, right? Nutan, I don't hear, right? So Geepa has not talked anything, single line. Okay, now going ahead. What this fan out meaning is? What is the meaning of the fan out? The number of cells are getting connected from any output of any of the cells is called the number of fan outs, correct? Now this is the theoretical. I actually don't rely on theoretical things. So this is one capacitance of this one. All the input capacitance will be here. Agree. All input capacitance. Agree.
Yes.
Now the equivalent capacitance at this output. This is C. This is C1. This is C100. C100. What will be the equivalent cap? Resistance in parallel. R what it will come? What will be the
1 upon R1 plus R2. 1 upon R1 plus 1 upon R2.
what will be the final?
R by 100.
R and R only. No 100. Okay. R and R. So this will be R by 2. Okay. If it is 100 R, then it will. Resistance in series, what will happen?
2R.
2R, because it will be adding. Now capacitance in series, what will happen?
C1 plus C2.
Capacitance
C by 2.
C
C
by
by
Sorry,
2.
sorry, C by 2.
capacitance
In parallel.
2C.
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 Now tell me, this is C1 and C2 is parallel or series?
Parallel.
Parallel, sir.
Parallel, sir.
So many of my friends will tell me that whatever they have studied in 11th, 12th, BTech, it is not helping them out. So I usually tell them to come to VLSI. I still work on R and C. Okay. So this is how it happens. C1, C2, C3, whatever it is there, right? Parallel capacitance. So it will be adding. So it will be 100C. Correct? Agree? C
Yes, sir.
plus C3 plus C is 100C. And now this is one. This will be in series. Right? So understand what will happen here. What will happen? This has increased. Correct?
Yes, sir. Yes.
Correct? This capacitance has increased. If this capacitance has increased, what will happen to this net? RC will increase.
Correct.
If RC will increase, what will happen? Tran will again, what will happen? Increase. Capacitance will increase, tran will increase. Tran will increase, what will happen? What will happen?
Delay will increase.
Delay increase. If delay increase, what will happen? Your timing violations will come. Correct? So this is how from this C to this timing violations we are coming. Okay. Now this is all the DRVs we discussed. Any doubt anybody is having here?
No.
No, sir.
Clear? Should I expect that you will answer the same way in the interview or better way? If you are better than this, I will be happy. Okay. So either this way or better way. Okay. Clear?
Yes, sir.
Okay. Now coming to next topic. Okay, Rupesh, to answer your question for the diff file. In the diff file, it will be written as we discussed, right? During the diff discussion, we discussed that code size is this much. That X, Y, X1 that we were discussing, right?
Correct, sir.
This we were discussing, right? So if you want to increase here, right? So this particular area, whatever the Y it is there in both the ends, this you increase by that particular micron. Okay. And I have already told you guys to write one script for the port placement. So with the port placement, you can do the port placement here. Okay. If we need to increase it in Y, we can increase it these two corners. That is where I gave you guys to work on how the notches are coming, how to start with, how to end with, whenever you are having the code design, code size. Correct? During the diff time we discussed. That is the reason. Now getting? So whenever you have questions, right? If diff related problem, try to correlate what all we have discussed. Direct jumping and coming, asking you a question, I'm happy to answer you. But first think what you can do here. What are the things we have? I always try to cover topics in a way that you will not have any doubt. If you will think on that particular, same questions can be asked in 4 ways, 5 ways, 10 ways, right? So this is what you have asked me in another way, that what if I will increase it, how we can increase it. This we have already discussed, correct? So this is not a very big thing. Clear, Rupesh?
Yes, sir. Actually, means why I'm asking you actually that one. While those people are doing, sir, manually, means there are some steps are there in doing while increasing or decreasing that 1x or 2x reduction. They are not writing any script, anything.
Okay. No need to do that. If you want to increase, right? One is from the floor plan side. You can do it whenever you are doing the floor plan. That cut you can create it. Second thing is hack the diff file. Hack diff file. This diff file increase the number. I usually hack this diff file. This is a very long and iterative process. The script editing and everything it will come. Okay. Calculation will come. So good. This way also you should learn it. Once you are best here, go ahead and I usually just hack it out. So this is the best way. So that is where I explained what is diff, why we are doing it, where we are doing it, how the notches we are creating, from where it is coming. Okay, clear?
Yes, sir. Yes.
Okay. Now, next topic is what are the next quality check for the placement? Come on. Next quality check for the
Legalization.
Legalization is the step. So, okay, again, coming to this one, global placement. Who said legalization? Global placement, legalization. What is the meaning of legalization? Jail placement. What is the meaning of legalization? Tell me, anybody. This is the placement stage. Global placement. Read it out. Okay. What is the meaning of legalization? Quickly, since someone said that, I will just explain it. I think so many slides. I have kept it for this one. This is there, right? Global refined for legalization. So what are all things we do, right? In the global placement, legalization, everything I tried to kept it here. Okay. What is legalization? Come, tell me.
Sir, so basically in the first step, it was global placement. In that, we do the rough placement of all the placement of the cells. But in legalization, sir, we try to like look into the deeper thing, like there should not be any overlaps and that thing. So the cells should be placed in their like original legal place only. So not the places that they should be like legally.
Correct. Correct. It should be at the legal place. So it should not be overlap. That is point number one. Point number two, the cells should be spread in a such manner that later on, whatever the global route we do, right, it should help that global route, right? These are the things we do. Like legalization, it should actually change the location of the cells to have the best placement. Okay, legal placement. That is like a legalization, legal. Okay, it is giving the legal location to the cell. Always remember that legalization, legal location.
Sir, in this legalization, we take care of overlapping of cells and within the core area, so we can do it correct if some cells are overlapping and
Correct.
like.
Correct. This is what Ashok said. Correct. So legal. One thing is like globalization. Globalization. That what is the meaning of globalization? So something we are doing globally, right? Something we are doing legally. So legally, that what we are doing here is a placement. So placement we are doing legally. Remember these words. Okay. These are English words. Okay. Coming to the next point. What timing, right? So next quality check is your timing. What are the different path groups that we have discussed till now? Quickly, who will say?
Like
Into
into
four path group actually. So first is into range, second is raise to range, third is raise to out, and fourth is into out.
Correct. So what are those? Okay, let me come here. So this is port. This is port. This is input to register, register to register. So register to register, it will always be clock to Q1 propagation delay, and then it will all the combinational cells, and then it is coming to the D pin of the flop, and then after here from clock to Q, and then this is the output delay. This is how we do it. So one path number one, 2, 3, and 1 is IO, input to output path. Right? This is also another port. This is also another port. This is input to output. This is not fourth. Okay. Now tell me, if you have violations, what are the things you will do here? What are the violations you find here? Setup, hold, recovery, removal. What are the violations you are getting it here? Setup. Setup.
Sir, setup violation.
Already discussed why only setup, correct? So I'm not going into that one. Now, if you are having raise to raise violations, how many types of violations you have seen and how did you get rid of that? That will be your one question for the interview. Tell me. Chalo, fatafat.
Sir, in raise to raise, there is setup violation.
Go ahead. Tell me, like what are the raise to raise violations? Any example you want to say?
Hello.
Go ahead. I just want to listen.
So basically in reg to reg we can see that we are having some combinational logic, right? So what we will try to do is we will just try to improve this combinational logic delay by just partitioning this combinational logic or optimizing it.
Okay, I just want to listen. Yeah, I want to listen from everyone, each one of you. Charisma, next is you. Tell me.
Sir, in raise to raise, we get setup violation because the data, we know that the arrival time should be less than the required time. So if sometime the data should be not present at that time, which is equal to or less than required, then there is a setup violation.
Okay, next, Ashok. I want to hear from everyone.
Yes, sir. So, like, sir, basically in Reg to Reg, sir, on that tool, sir, like, I haven't seen that thing, but in theory part, like, yes, there is a setup violation, and to fix that, we insert buffers. And yes, sir, that there was one question like we insert buffers, like, and where should we insert that, like near to the launch flop or capture flop. That.
Okay.
So,
Yeah, go ahead, Arpita.
so actually, we are getting setup violation in the rest to rest path. We have to do three things, like we need to decrease the launch clock path delay, and we have to decrease C2 Q pin delay, and we have to decrease the data path delay. For this, we can add the buffer in this path.
Correct. Okay, next, Jatavid.
Sir, actually, sir, with respect to clock, we have to consider, I mean, a lot of paths as well, sir. For example, a source path. So, with respect to source path, and I mean, with respect to source path, also we can, we can reduce the setup delay, sir. So, basically, we can do early clocking, sir. I mean, if the clock path is late, if you do an early clocking, we can we can reduce the setup timing, sir. And as she said, sir, with respect to combo delays, we can also add buffers to reduce the combo path, sir, so that we can meet the timing requirement for the setup.
Okay, this is another point. So why I'm asking this question is, again, I will go to one by one, but I'm asking like, till now I have not given you anything, but since I know that every one of you have come from training and going for interview now, so I just want to understand, like, if they will ask you that any scenario that you can tell me about how you have get rid of your timing violations, then what will be your answer? Sekhar.
Sir. Yes, sir.
You don't have much time. Quickly, whatever it is coming, think. I will come to every one of you. Think.
Yes, sir. In this to rest path, we'll get setup issues because the logic that may be more. So we'll optimize the logic, combo logic.
Optimize the combo logic. How you will optimize that? So tell me, for everyone I'm asking, like, why timing violations will come here at the placement stage? Why? What is the reason? See, theoretical things is different from practical things, right? Try to understand first why timing violations are coming at the placement stage. What are the reasons that we discussed, right? Because of the TRAN, what are the reasons for the TRAN, correct? Agree?
Yes, sir.
Similarly, we need to understand why timing violations are coming at the placement stage. If you will understand that analysis, I will tell you again, I will not discuss the solution. You will only tell me the solution. But first understand why.
Because there are more number of cells added in the placement stage.
Correct. That is one point. Now coming to your question, this is a good answer I heard. Now coming to your answer, Pooja, why those number of cells are coming into the picture? Now we are going in direction. I have written here, right? This is a combo cell. This is clock to Q. So now I will take it out this outside. Who got the company? Who got the company?
Shrikant.
Good one. Okay, no problem. So let's understand this. Okay, this is let's be here only. Okay? Try to understand what is happening is here. I told race to race path. So race to race path are having these two kind of paths. It will come. So one I will do the clock one. Clock one. Clock will be like this. Okay, this is a placement stage. There is no buffering here at the clock stage. Now combinational cells. One cell is here, one cell is here, some big cell, one cell is here, one cell is here, right? Like this it will be there. And I left out this is this is this coming like this it is coming. Other pins are driving somewhere else, like that it will be there. Okay, this net length is somewhere 200 micron. Okay, 200 micron. Now clock to Q here. So one by one I will write down the delay, and the right side I will tell you how the arrival time is there. So basically setup is what? Required time minus arrival time, correct? Simple. Let's make it simple. So first segment it will be written as arrival time of your report timing. Second segment will be required time. This will be arrival time. So arrival time is what? Starting from this point to this point. Agree? Starting from this point to this point. Agree?
Yes, sir.
Required time will be the entire path, whatever it is, this path, correct? So basically not only this path, whenever it is required time, it will be there, right? So starting from here to here, we will have the clock paths also, right? So required time, now coming to the path here, required time. See, I'm going very quickly. I'm not going deep diving it, but a very good bite I want to give you on the timing analysis. So how it is coming? Starting, listen, everyone, be careful here. So path number one is this one. I will take another color here. Path number one is this one. One. Clock to Q delay. Two will be this net. So here net is not there, correct? No net routing has happened. So RC will be estimated as per Elmore delay or like some basic delay calculation. But from here to here, some delay will be there, right? Then cell delay will be there, 3. If net is there, then only it will come. Okay. Otherwise, what will happen? Let's not confuse you guys with the routing. So this will not be there. Let me remove this. Let me remove this. So this net delay we are not calculating here. Correct. So this will be your number 2. This will be number 3. This will be number 4. This will be number 5. And it will be number 6 point will be like this. Okay. So in your arrival time you will see this is the launch register LR. This is capture register CR. So it will be writing as, see, I'm writing the entire path like this. I will try to make the best best out of it in a quick time for this timing path. So one will be this one. So delay 1. So one will be this one. LR cell will be there, instance will be there, and here it's an incremental delay will be there, INCR, and here delay will be there. Two things it will come. This incremental delay, how it is coming? It's 1, right? So from here to here, number 1, whatever the value, it is, just imagine 10 PS. Okay, everything will be in PS only. So it is 10. Incremental is 10, here it will come 10. Now for this cell, imagine it is 5 PS. So incremental is 5, total is 15 now, right? This is cell 1, this is number 2, this is number 3, number 4, number 5, number 6, till D of this one it will come. So second one is this one cell, this is C1, C2, C3, C4, like that. It will be written in your timing path. So 2 will be here, C2, C3, no, where it is, correct. C1, C2, I took it. Okay, so this is C1 only, this is C2, this is C3, this is C4, and path number 6, this is CR, right? CR slash D pin. So this is C1, C2, C3, C4, 4 cells, C1, C2, C3, C4, 4 cells. So 5, imagine this is 15, 15, this is 20, this is again 10, and here whenever it is coming, right, for this cell, it is 40, 40, for 40. So delay is 40. So this is 5. So now here 5 we have added. Next is C2. C2 is this one, 15. Incremental is 15. So this 15 plus 15, how much it will be? 38. Quick here. 30. Quick. So here, now cell 4. This is C3, 4. How much it will be? 20. Now delay will be, total delay?
50.
50. This is 10. What it will come here? 60.
60.
Correct? Now for this one 40, how much it will come?
100.
100. So 100 PS is your arrival time, right? And if your required time, overall required time, what it contains? The time period, right? Time period minus setup uncertainty, right? Minus what are the things it takes? SQ is not there, right? Setup uncertainty is there. Library setup time, right? These are the required time it comes. So if taken into the picture all, if I have this, imagine if I have this as a 80 PS, overall 80 PS. This is 100 PS total. This is required time is 80 PS. What will be the slack? Practically, what will be the slack? 100 minus 80 will be 20, minus 20, correct?
Minus 20.
Why? Because required time minus arrival time, 80 minus 100, isliye minus 20. Now tell me this kind of paths, what you will do? From where you will gain this minus 20 on this one? There are different reasons it will be there. One is, this is very big cell. That is where this one is coming, right? And this is having 20. So we have to find out why this, your analysis point of view, you should find out why this is 20, even though this is small cell.
Reliance ಟೆಂಡರ್ದಾಗ ಆಫರ್ ಇದ್ದಿತ್ತು ನೋಡು, 8,000 ಪರ್ಚೇಸ್ ಮಾಡ್ರ 4,000 ರೂಪಾಯಿ ಕೊಡೋದು, 8,000 ರೂಪಾಯಿ ಬಿಲ್ ಮಾಡೋದು, 4,000 ರೂಪಾಯಿ ಕೊಡೋದು ಅದ್ರೊಳಗೆ ರಿಲಯನ್ಸ್ ಟ್ರೆಂಡ್ಸ್.
Nutan, you are talking or you can mute yourself.
ಎಲ್ಲ ರೇಟ್ ಎಷ್ಟು?
Hello. Okay, so what will be your analysis here?
So analysis is there. Some cells has more delay and some cells are big present here. So we will analyze those cells and resolving that issue.
So to decrease the delay, we can go for VT swapping for those cells.
We can go for VT swapping.
We can increase the drive strength of the cell so that delay will be decreased.
Correct. This is another point. One is VT swapping. Second is increase the drive strength.
Increase the drive strength.
Solutions. Okay. Again, you guys are coming to the solutions. I'm asking again that what is the analysis? What is your analysis? Why it is happening? Think in that way. What is your analysis here? First, you should find out where this, why this 15, why this 20, why this 40 has come. These three are bigger numbers, right? Compared to 5, 10, 15, correct? So, first thing first, I said here 200 micron is a wire length. You need to see why the wire length is there and what is the tron here, right? That if you will see this 40 might come down. That is one point. So first you need to understand why this wire length is high, correct? Second point is why this is 20, whether that is small cells, it is driving bigger cells. Because of that, capacitance has increased. Then tron has increased, delay has increased. Getting my point?
Yes,
Third
sir.
point is this 15 is why this is high. This is a bigger cell. The cell delay is only very high. Can we swap this cell? So now we'll come to the solution. But first understand why those bigger numbers are there. Correct? Okay, so this detailed analysis actually, okay, let's leave it. We will discuss everything during the timing analysis. Again, path by path, we will discuss it. Practically, what you should do. Practically. Theoretically, if you're going for interview, right now, understand what the VT swap will do, what the drive strength will do, what the insert buffer will do, right? If you, this cell, small cell is there, right? What kind of things it will come.
So can we add delay in capture path?
What is that?
So can we add delay in capture path?
Delay you want to add, what will it will happen with the
In capture path to improve the slack. I'm asking, is it? I did.
Come again.
Sir, I'm asking, can we add delay in capture path?
So why you want to add the delay in capture path?
So to improve the slack.
How it will improve it?
So right now we are getting -20. So if we add delay, and suppose if we make it 120, so the slack will be 20.
Okay, so you were talking about this path, capture path, right?
Yes, sir.
Clock path we are not discussing about this. This is at the placement stage only.
Okay, sir.
We can discuss that part, but that is the end thing that we do. Data path first understand. Okay, how many of you are clear with this?
Clear, sir.
Yes.
Yes.
This is very
Yes.
basic. Okay, if you know the timing, how it is coming,
Yes.
and this is a very basic of the timing analysis. Very basic. I'll start with these kind of paths only, before telling you all the basic examples, and then I will move ahead. Okay, so this is how you should work on the timing analysis. Second thing is like CTS. What are the steps for the CTS?
So basically in CTS, the real clock come into the picture. Before CTS, we don't have real clock.
What we do? What are the steps?
Sir, in CTS, we deliver the clock to all sequential elements.
अच्छा हम क्या करेंगे मतलब अभी तक क्लॉक बफर्स डोंट यूज होता है और डोंट यूज निकालते हैं ये ना पहले करेगा वो ब्लॉक डिपेंड करेगा पहले हम क्या करेंगे एचएफ लेने से
Okay, so what are the steps for the CTS?
Build clock, route clock, and manual. Yes.
Okay, so those are the basic compile fusion steps, right? So correct, but what are the internally we do in the clock CTS? Okay, guys, so I will give you the questions. Just guys go through it because I have not taken classes on this one, so if I'm not expecting very good from here. So okay, so CTS wise, three things that will be there. Like one thing is like, what are the steps for the CTS? Okay, steps of CTS. Go through it. Second thing, what are the quality checks? Quality checks. So in the quality checks, what are the things that will come? Quickly, point wisely, if anybody want to tell me. Quality checks.
Minimize
quality. Huh?
Minimum skew.
Skew, correct. Skew should be minimized. Minimum skew, correct. Okay, next.
DRV should be maintained low DRV.
What is that maintained? Come again.
Minimal congestion.
Sir, power.
power is one time.
Power dissipation is under limit.
Okay, first thing first, if anyone is going for the CTS quality checks, you will talk about skew. Second, you will talk about latency. Okay, latency. This will be done. Then you will go for power. Okay, one by one. Power, crosstalk,
Noise.
mean pulse width. Noise is coming in crosstalk only. Mean pulse width. Okay, mean pulse width. These are the basic, like, basic quality checks that we should talk about. But first, it should be skew and latency. It comes to condition also, like now, because cells has been again, clock cells has been inserted, so this will also there. But at the end, one after another, we will talk about these topics. You go have revision. What are the things it will come? Okay, this is one thing. Once this is done, after the route, what are the steps of the route? Route steps, okay? Route steps. Then after, what will happen? Quality checks again, quality checks. DRCs, physical DRC. Physical DRC, okay? This you will check. What else? Route. Look for VRs. What are the VRs that you are using? What kind of metal layer you are using, right? These things you will check in route. IR drop analysis, because whenever you are saying in your resume that this you have done it, they will ask questions from here. Time analysis, we discussed many things. Timing analysis, we discussed many things. Once this will be done, then after IR is that physical.
EM.
IR EM is it will be here only.
Sir, antenna effect.
IREM. Antenna here itself. Antenna, these topics you will study. And we did not discuss about the inputs, right? So inputs also take a revision. Inputs, right? Take a revision, and then accordingly you can have. Try to give you the best in this way, like one by one, whatever we have discussed. Okay. Synthesis, if you guys are saying, some of you that synthesis, then synthesis you can have. Okay, these are the things. Okay, any questions from you guys side? You want to, like, any doubt you have? So this is from my side. I wanted to give you this many, like, heads up. Anyway, we are going to discuss each and every part in a very detailed the way we are discussing it. But right now, anything that you want to ask me?
Sir, can we get the CPP and row height values for different technology nodes?
What is that?
Like contact polypitch values and row height values for different technology nodes.
See, row height values, it will be, values, no one will ask one thing. If people are asking me also, I will tell them that I don't know. Okay. And second thing, with the row and height value, cells are being double height, that we have already discussed during the synthesis, that single height cells, double height cells, right? That it will be, people will be asking you that whether you are using, why we are using, where we are using logically. Values, people will not ask. A few interviewer might ask you the command side, but generally interview questions, people generally don't ask the commands also. That is another part. But if you have good knowledge of commands also, this is good. People might ask you, right? People will actually look for your analysis part, how you are doing the analysis. Okay. Any questions from the any part?
Sir, in a block, if no one sequential element present between the in to out paths, then what's the role of in to out path?
In to out path, I told you, right? Some logics are coming from here to there for different partitions. So somewhere registers will be present.
Okay.
It's just like for you it is not visible, for top level it will be visible.
Sir, we can't define this in to out path as a false path.
False path is something different, right? I'll tell you why we define the false path. There are a number of reasons that false path or multi-cycle path. The paths which we actually don't need for the timing analysis, that those paths are there for some different other purpose, right? That those paths only we defined as a false path. like power good signal. There are many others. So once we'll discuss the false path, right? My mind will be there, and I will tell you all the, what are the reasons. Mux select lines. There are so many things, so many situations that we need to define the false path. So being a steel engineer, we should know that where the false paths should be defined.
Okay, sir.
And from the architecture, you will get that these paths are like not the timing paths. So from there, you need to define it that this is false path. Okay.
Okay, sir.
Sir, I have one question actually. I have read one somewhere else. Why micro height is more and standard cell is less? Sir?
Why macro height is more and standard cell is less?
Yeah.
So I don't know from where why people keep this. Think of it. Why? Macro is the IP, right? That IP contains all the standard cells. Definitely, if 4 standard cells will come, right, in a particular area, your height will look more on. Correct?
Yeah.
Then what is the reason for this question? Someone want to write something, then they just written something. Correct?
Yeah.
Just waste of the time. I don't know why. Okay.
Sir, actually, I had a question, sir. It's like a practical question, sir. Sir, for every step, we'll get a utilization ratio, right, sir?
Right.
So, will they actually ask the utilization ratios for the projects?
They might ask you that what was the utilization you started with, and what was your utilization at the at the placement stage, CTS stage, like at least CTS stage. Why they are asking is that they just want to know how many clock cells you have in circuit, and then they will ask you what happened to your power. Then they will ask you what happened to your condition. Then they will ask you if that is the density, then what is your condition, how your shorts are coming, right? All the quality checks they will merge it there. So these kind of questions might come. So always keep that in mind that your design has got 2 to 3% after CTS, and during the whole optimization, since the delay are getting added, it is like 5%, 5 to 6%. Don't go beyond that. And always say that my design utilization was started with 55%, 50%. Don't go on 60, 70%. They will have so many questions from there if your interviewer is good. If I will be there and if you will tell me, right, your utilization is 60%, I will ask you so many questions from there. Okay?
Right, sir. With respect
55 to 60 or 60, don't go. 55 or 50, don't go to the number 50, 55, 60 like that. No, 53% it was there. 53.5 to be very good. It is looking realistic, right? 54.2. Don't go like 55% or 56% like that, and then say that at the end of the readout, how many times he's joining and he's going. What is happening? So then you can see that 53.4, and different people answer differently if you are going for same interview panel. It should not happen that everyone is going and telling the answer. My utilization was 53.5, 53.2. Have some different. 48 is also okay, right? No problem. But be in between 45 to 55, right? Starting during the placement. Then increase 4 to 5%. So if you are saying that 52.5, you go ahead and say that 57.2, I close the design at the router space. Like that you can say.
Yes, sir. Actually, I have a question,
Sir, I have read somewhere we should take this utilization between 60 to 70% at the floor plan stage, and after that you will go increase the after routing it reach to around 80%.
I will tell you what happens is nowadays, like many blogs people wants to write, they have not done a single design also, and they will try to write the blog. So that is where these questions are coming, these things are coming. Understand, now also if you are doing that, right, designs are good, but you will be having so many issues. If you are closing the design with 80%, right, understand at the ECO stage what will happen, another 2 to 4%, right, 80 to 85%, now 85%. Understand from there how your IR will look like, how your condition will look like, how your physical verification will look like, right? So you are going in a very bad range. I will tell you, yes, I have also done so many designs where my utilization started with 78%, and I ended like after a readout, and then I ended almost like 84, 85% at the ECO. But that was very critical design. That was not a normal design, right? So every time you won't be having like that. Most of the like mobile processor companies, they are having high utilizations, and most of the time whenever the automotive companies are there, right, they will have this utilization because the area is not the concern for them, right? To understand, like, why if it will happen, there are so many issues will come. And if you are saying that your utilization is 70% now itself, they will ask you so many questions that why this, where that. So being a fresher, don't go with a higher utilization number if you are going for an interview. Don't.
Okay, sir.
Sir, I had one more question, sir. Sir, with respect to the technology node we are working on, for example, for 14 nm, for 40 nanometer, I can say like my utilization ratio was around 45 to 50. Like I'll tell a specific number, sir. But for 22 nanometer node, like I properly don't have any idea, sir. Like what is the
utilization is a number, right? So basically in 22 nanometer also, if you will see different blocks, different tiles, different partitions, they have actually different utilizations, right? So it does not depends on your technology node, first of all. It depends on your how many standard cells are there occupied in that particular area, right? So if that is the case, then it depends on that utilization. Some area, whatever the area we have cut for some particular partition, might be 55%. Some might be having 30% only. I have seen the design utilization 30% also.
Okay.
That is also not so good. That if that 30% also you are saying, right? So many questions will come. What happened to your timing? If you will say it was good, people will not take that. People will say that it cannot happen.
Okay, sir. So actually, like utilization ratio doesn't depend on the lower technology node also. So even for lower technology node also, for floor plan, we might have a lot of utilization ratio, right, sir?
Come again.
Sir, even for lower technology node also, we might have a lot of utilization ratio in floor plan itself, right, sir?
Correct.
Okay.
And see, the utilization, what is utilization? First understand. Whenever you are asking, like you asked me 3-4 questions, right? I was thinking you will take it from here. Think, what is utilization? What is the formula for utilization?
Standard cells plus the macros and divided by the total area they occupy.
Correct. Think. See, what happens is, like in your particular design, standard cells are there, right? So how many standard cells are there? If I'm having 1 million instance here, 1 million instance, and that area, whatever this area is there, right? Whatever this area, in this 1 million area, if it is giving me some 50% utilization, 1.2 million, whenever I'm increasing the area, 1.2 million, it will be 60%. So how much area you are utilizing, utilization, how much area you are utilizing in that particular partition, that particular tile is called as utilization. So how much you are utilizing? That means if I say I'm utilizing 60% of area, that means 40% of my area is empty.
Right.
Okay. And it's not that one side is empty and after that one after another standard cell is sitting. Practically it is not possible, correct?
Yes.
So how it is coming is, entire design is distributed. Only thing is like few distances will be there like this, right? Then only our routing will be happening properly. Otherwise congestion will come.
Right, sir. But in terms of practical aspects, sir, if there is a 60% utilization ratio in the floor plan itself, then we are doing a lot of stages, right, sir? After that, I mean, we are doing a CTS, sir, and after that, we also, I mean, in CTS we place a lot of cells, I mean, buffers and inverters, sir.
Correct. Correct.
So,
That is what it happens if like you started with 50% utilization, right? 1 million instances.
right, sir.
What will happen? Some like 1.1 million instances after CTS, okay, or might be 1.0108 million instances, like 80K cells has been increased. Okay, so what will happen here? Your utilization might increase to 1 or 2% here, 52%, 53%, like that. It will increase. Okay. This is what you understand. Utilization we discussed during the floor plan. I don't know why. I mean, it is again creating trouble. Utilization is a thing where how much area basically it is occupied by the cells. It's not that technology dependent. It's totally depends on your planning, your top planning, how much they are cutting and giving it to different partitions. Different partitions are there, right?
Yes, sir. Right, sir. Sir, but I had last doubt, so I'm sorry. I'm so sorry for
No, no. Hey, for doubt, no sorry. It's just you need to understand things, and whenever we discuss the things, right, we can discuss again those things, but try to think. My problem is, I will tell you what will happen. Maybe we are here for 3-4 months, right? 3-4 months, another 2-3 months, whatever it is the time, or maybe 6 months or 1 year, whatever the time I will be here, right? After that, what will happen to you? Think. I will be accessible. I know that I always whoever spend time with me, like being my candidate, I will always be accessible. But I might not be accessible like this the way I'm here right now, right?
Right, sir.
So you will have to think, you will have to do in the same way, right? My purpose is like I always think like the way I think, I feel when I actually try to make people in the same level or the better level what I am here right now. I always try to do that. So that is where I say think, always think what is happening, how utilization is affecting, how it will happen. Yeah, go ahead, another question.
Sir, actually, sir, before flow, like in floor plan, sir, we are not adding standard cells. We are not even going for optimization, sir. So basically, there will be a very less cells. So basically, with respect to that, if the utilization ratio is already 60%, sir, then does this not make a good sense, sir? I mean,
no. Okay, good question. So this is very good question. That is why I say there should not be any sorry for asking questions. Okay, if you are not understanding or next time if you are not telling, then you should be sorry for that. See, I will tell you whenever that area, whatever the standard cell is there, right? Whenever you import the design, netlist is imported. Correct?
Yes, sir.
Netlist is the first thing we import the design is a netlist, and then after we go to live everything, all the file, MMMC, corner creation, everything we do.
Yes.
That time, if you will see, with this side, all the standard cell hierarchy will be there, this side. And this side, all your macros will be there. All macros will be there. Okay?
Yes, sir.
What happens is, this area and this area tool is having it right now. So now, whatever this die size you have given, right, tool will actually calculate based on this area and this area. If your netlist is wrong, then only your calculation will come wrong. Otherwise, to have this information, we have this information. That is why I rounded it up before your question itself. I made like this because I was knowing that what you were going to ask. So this is how the calculation happens here. Okay.
Okay, sir.
Sir,
go ahead, sir.
They ask what is the distance between the macros in your design?
What is that?
Distance between the macros, channel length between the macros. How much?
That depends on technology to technology. Okay, that is true.
In my project, I have mentioned 28 and 40 nanometers. So, how should I answer that question if they ask?
It should not about how you should answer them. It should about what you have written in your resume. How did you place those macros? What was the distance it is there? I cannot remember for 22 nanometers, 30 nanometers, every nanometer I cannot remember, right? So you should know that how much the distance you left in between these two.
Yes, sir. Approximately, what is the number that I can?
If I will tell you approximately, I don't actually believe on approximately. I will tell you why. Approximately will kill you. So, whatever you have done last time, right? Try to remember that, and whatever you are updating in your resume, try to update according whatever you remember from there. Don't just go blindly and approximately. There is no word called approximately. Right? Number, even interviewer must not be knowing that what is the distance between these two. They will just ask you. You should know that 0.58 or like 2 micron you were saying leaving here, or like just take that how much the number it is. Okay.
Sir, I think user manual have those information.
Yes, that's what I'm telling you.
Guys, like just go with the user manuals so that you will get more information from that.
Correct. No one will remember. If you will ask me, right, last to last project, I forgot actually that number.
No, actually, these people are reading from too many things from the blog. They are getting too much confusions. It's better to read from the user manuals.
Correct.
Even I prefer user manuals. I'll do some go through those manuals like ICC2 or whichever tool which I'm using. I'll go with the manuals itself.
Correct. So remember that those things, right? And blogs again, I will tell you, right? I have seen people; those have not entered into the VLSI also. They have not done a single project. Also, they are writing the blog. So that is the another part that is actually creating confusions. Okay, any other question?
No, sir.
Sir? Yeah, I mean, I have mentioned 800 megahertz in my resume, sir. What if he asks what is the WNS value you get in the synthesis placement says like that? What if he asks?
Yeah, that number it's good. Like, but again, I will tell you, WNS again depends on what. Reverse negative slack depends on what. See, numbers, if you will tell me, right? Actually, I don't depends on numbers. So again, what will be your this number? It will be. If I will tell you, right, you can go ahead and you can tell them that 800 megahertz, right? At the placement stage, the 100% of that one, it will be how much? 800 PS around. So tell them that it was around 1 ns. Okay, and tell them that the buckets were like that. You can change the lines here. That 1 ns was a WNS, but there were very less violations at the top level. So majority of violations were under 400 PS. So my placement was looking good, but few paths we had high violations because of the tran, whatever we discussed, because of the fan out. So that those we cleared it out with the next iterations of the placement. After that, it reduced to almost 450, like, or the 500, 550 PS. Again, don't go by 550 and 450 like that. Go by 478. Okay, like go by 518, like that. So these numbers. So like that you can say. So the 100% of this one is it should be lying in that number, particular number. That will be your good answer. But whenever you are doing some designs, I don't know why you guys are not keeping the data that if you have, right? If for my interview, if someone is asking me, I directly say that I don't remember that number. People are happy or not happy, I don't care. But I generally don't say that. But if you people are asking, right, you can go ahead and say that if 800 megahertz, right, near to that number, you can say like 800 PS or like 900 PS, 958 PS, some 912 PS, like that. Any number you take it from here, and you can tell them. Okay, any other questions, practical questions or something? See, again, I will tell you, if you are clear with your answers, right, it will help you. Be clear with what you are talking about. Bluff is also okay, but people will catch you whenever you are bluffing, right? People will catch you. So if people are good, they will catch you. So try to be the best, but don't try to bluff. Just revise things before going to the interview, and be confident. You should not have fear anywhere. Be confident whatever you are talking, whatever you are saying. Analysis wise, I have already discussed so much of analysis, right? Till now, whatever we have discussed till floor plan. So I believe till floor plan, if you are getting any questions, you should be able to answer, right? Okay.
Yes, sir.
If not anything else, then I will leave you guys today. Sunday is there, and second part is like you guys have, so many of you have interviews also, right? So you can, if you want, you can ping me for any questions still if you want. Otherwise, keep preparing for your interview and try to give your best, whatever you can give, right? Many times you might not have second interview, or maybe it will take more time, right? Depends on the current scenario in the industry. So try to give your best what you have. Okay.
Which company interview they are giving, sir?
They have different companies from there on different, right? So it's not from the VLSI tutor, from their side itself. It is there. If you want, we will try for you guys. Like whoever wants from VLSI tutor, we can try for that. But till now, what has happened? Problem is, we have not discussed a lot. I want you guys to discuss everything before going for interview. Right now, if I will send you, right, see the scenario, what it is happening is like, theoretically, you will say that if your interviewer is good, he's not actually looking for that part, it is good. But if people are looking practically, right, it will be a trouble. Right?
Sir, any other points we should keep in mind, sir, with respect to interview, other than technicalities?
Communication wise, be good. Confident wise, don't be over, don't be under. You should not have fear. Second part is like have copy pen, everything I said, right? Try to first map the thing what you are going to talk before jumping on it. Second thing, today also you saw that, right? If you are talking about analysis and debug, it will be clear, clarity will be there, and then jump to the solution before jumping to the solution. And if people are expecting, actually depends on your interviewer. If he is expecting only solutions, go ahead, just fire all the solutions, fire. These are the things, and go point wisely always. Point wisely, 1, 2, 3, 4, like that. So your finger should be 1, 2, 3, 4, like that. Your finger, you will be counting it. And this is one I did, second, third, fourth, like that. Okay.
Okay, sir.
Answer slowly, guys. Like that is one more option.
Correct.
Like if you answer too fast, or you will get stuck at some point. So analyze the question for 2 to 3 seconds, then answer it.
Correct.
Okay.
This is a very good point. If you are in rush, right, you will confuse yourself, you will confuse interviewer. That is another point. Be calm.
Yes, sir.
Okay, then if we don't have anything, guys, please carry on with your preparations. I would suggest again, whatever the topics I said, at least be clear on those topics. It will help you during the interviews. This is much from the freshers what people will expect, not much. Right? Okay?
Yes, sir.
Okay, chalo, all the best. Take care, guys.
Thank you, sir.
Bye.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
Bye.